So in the last video then we made the parts for our drill stand. So we made the bottom plate, we saved it as top plate, and then we made the top plate. So rather than do the triangle, the rounding and putting these three holes in again, we just used the same file and order and just saved over the top of it. Or saved it as top plate. I shouldn't say overwritten it because that's not what we did. We then made a sleeve, which was two circles extruded into a tube, and then we made our threaded bars, which are going to hold all this item together in order to form this assembly. So I think I said in the last video I've not saved any of my parts. I've already got them, so I'll just use my named parts rather than part 2, part 3 and part 4, which is what I made last time. So in order to do this then we're going to load a new assembly file. So we go File New, click on that metric folder. If it's not there, remember there's a little right arrow, must click on it in order to get it, and then we want standard millimeter.ipt. Now, first thing that we need to do in assembly is to place in the first component. I'm going to place in bottom plate, and I'll just click once. Now just remember it will try and ghost in another one. You don't need two bottom plates. That's really handy though when we put the sleeve in and the threaded bar, so we'll talk about that when we get to it. And the first thing I'm going to do is ground, or make that one grounded. That means I can't move it around. Okay, really, really important when you start an assembly, always ground the first component that you put in. It's usually one of the main parts, so I wouldn't bring the sleeve in or the threaded bar in and bring in that particular one in to the part. Now I could, if I wanted to, bring top plate in now. However, I can't really assemble top plate to this one yet because I've got nothing else there, and if I was to mate it and flush it, it would just sit kind of level with this one, and it obviously wants to sit a set distance apart, so that might not be the best option for what we are doing at the moment. It would still work, but we'd have to probably work out a little bit of an offset in order to put those in, so maybe not the easiest thing to do as yet. So what I'm going to place in first is I'm going to place in some of the cylinders. Now I'm just going to put 3 in, and I'm going to put them roughly near to where they need to be, and I'll press escape so I don't put any more in. So maybe one of the first things we could do here is pop these sleeves over the top of these holes. Then we could put the top plate in, and we've not then got to worry about the offset because I can do that. So it's a round item. Okay, when we generally put constraints on round items, it is usually insert. If it was a round item to a square edged item, we may need a tangential constraint. I very rarely use that one whilst I've been doing everything that I do on Inventor. So we can click on one edge, and then again we've got the option, we could click on the front edge or we could click on the back edge there. So really important that we just try and get the onto the correct one as we're doing. So this assembles together fairly quickly. Okay, so we've got our 3 sleeves on there. So if I click apply, now they'll not move, but they would, technically they would spin round. Now because I've coloured it you can't see the rotation, but we've not stopped it from rotating, we've just attached it to that central axis through the hole in that particular bit. So we'll bring in top plate now, and again I'm just going to have to look round the shape a little bit here as I go to constrain it, or I might be able to zoom in and see the back edge of this possibly as I'm doing it. So yeah, if we can see the back edge we don't need to rotate round, but I could just put that one into there and click apply. Now just to show you, you don't need to do this as you're doing it, but that's only attached it to one of them, so we need to attach it to at least 2 here in order to stop it from moving. So if I just move that away a little bit just so you can see that when I do my next insert, I'm going to click on this one, again the back edge of this one, and then I can press apply. So although I've only put 2 constraints there, okay, this bit can't move away, the sleeves can't move away, and obviously I've grounded that object. So what I tend to do a lot when I'm in assemblies is to pan around the screen. Now to pan around you can use the hand icon here. Okay, that'll pan around for you. What I tend to do is just hold the scroll wheel down on my mouse, and that changes pan. So I can scroll it to zoom and I can pan around. So as you're trying to move around an object, it's really useful that rather than having to keep coming over and going pan around a little bit, turn that tool off, then I might need to rotate round a little bit. You know, we know that if we hold F4 down on our keyboard, that allows us to rotate, I can zoom with my scroll wheel, I can pan by holding my scroll wheel down. So again, just a couple of hints which are pretty useful as you are doing this kind of stuff. So next thing we need to put in is our threaded bar then. So again, we'll place the component that we've made. And again, I need 3 bits of it. So you can see the benefit of it ghosting another one in. If we needed 20 of these in a component, I don't need to go place, click OK, place, click OK. I can just put as many as I require. Now, similar procedure here. We're going to insert these into these little bits. Now again, I've got the benefit of having that the aligned and the opposed option here for the solutions. Now, in this case, we've got too much stuck through here. We need this little bit. So we're going to have to put a little offset in. We're going to have to adjust these a little bit. Now, if we, what's the best way to explain this? So if I just turn to the right, if we think about as we've made it, our tube is 25 and our thickness of these is 3. So we've got 25 plus 3, that's 28, plus another 3, that's 31. And we've made our threaded bar 43. So we've actually got a set distance here. Now, let's say you couldn't remember what you were trying to do. I've actually think as well, I've done this to the bottom of the chamfer, not the top of the component. So I'll just press cancel on there and I'll just redo that just because it's going to make the numbers slightly different. So I'm going to zoom in and just, I've actually must have selected this one as I've done it. So we'll click on this bit, then we'll click on there and that's going to hide it perfectly in line. So let's say we don't know what it's going to be. We couldn't remember what the thickness we couldn't remember what the length of this is, and we need to try and get this central in this little bit. Now, the possibly easiest way of doing this is initially if we press apply, and then I'm going to go onto inspect, and I'm going to grab this tool called measure. Now, if I just spin around the shape a little bit, I could ask it what measurement it is. So if I say from the end of there to this bit here, and you can see you've got a little ruler icon next to your pointer there, it will tell us that that is 12 millimeters. Okay, so we've got that extra little bit of information now. It's 12 millimeters stuck out. So if I want this halfway, obviously I need to put an offset in of 6. I need to move it 6 millimeters one way. Now, I've already set that constraint, so I can't just do another constraint now to do it. It's already got one. But if I click on the bit of threaded bar, it will highlight which one it is here. So it was threaded bar :1 in this case. So I'm going to double click back on this mate and I'm going to change my offset. Now, when you type this in, sometimes it'll go the wrong way. Okay, if it goes the wrong way, it's also come off thingy. So for some reason I did it as a mate, apologies, and I did not do that as that. So I'll just pull that back out and we'll just have another look at that. So constraint, insert, grab that little bit. I think it's because I was talking to you about this, I've not selected the right one. So we've got an constraint in there and we're going to do an offset. Now if I put 6 in there, sometimes it goes the wrong way, look, and what we need to do is just put a minus in front of it and then it will offset it the opposite direction. So we've now got 6 millimeters stuck out either side of that particular bit, and we'll go apply. Okay, and we can repeat that 3 other times. So again, get a little bit of practice in here. Make sure you're trying to click from the right bit. Okay, into there, and we want an offset of -6. So we'll apply that one. Now it might be sometimes you do one. Let's see if we can do it just for the purpose of the video. If I click onto the other edge this time, so if I do this one to the inside of that hole, and I type 6 in there, no, it's not doing it anyway, but sometimes depending on which way you click it, it might not need the minus, it might actually need the positive value in that case. It's not done it in this case, but so we'll go apply there. So we've now got our threaded bar into position. So the little cap nuts, we could make them. There's kind of no point. Inventor's got a huge wealth of pre-made components for us, but they're not just using place. We actually need to click on the little lower section here where it says place, and we're going to place from something called the content center. So the content center is loads and loads of pre-made items. I've just been in it, so we're going to use this 4th one along. But when it loads up, it looks something a little bit like this when you load it, I think, on your screen. So it comes up with cable and harness. Now, inside of here, we've actually got a huge amount of pre-made components which you may want to use in some of your projects. Now, tend to be the ones we use a lot of these fasteners and maybe some of the sheet metal parts, but this has got a huge wealth of different type of bolts. So if I go into countersunk bolt, these are all individual pre-made items which the people at Autodesk have made for you. And again, if we go on to this next one, we've got a load of what we call flanged bolts there, which have got a built-in washer into them. But again, this folders with loads and loads more in. So there's actually some multiple thousands of different things here. So again, we get some others. So we get these little kind of hole bolts, these wing nuts with a bolt already in them. There's loads and loads of things to stop you having to make it, basically. Studs, so we've got bits of threaded material that aren't threaded all the way, but I've got no head on there. We might have got some with a slot in there, so you can put them in with a flat blade screwdriver. But there's loads and loads of things in there, not just in fasteners, but again, loads of different types of nuts. So again, we've got slotted hex nuts, and we can kind of appreciate how many pre-made items there are here just by what we've done. This is one we've used before. I want to say we used maybe this one, or maybe this one when we did our depth gauge. So again, loads and loads of different types of things which you could pick out. Some quite bizarre ones. So if there's certain things that you need, certain shapes and bits, we could pull those out without having to make them. So loads and loads of components that sometimes are really useful for us to save us a little bit of time in order to do it. So in our case, we want a fastener. We want a nut, we want these nice domed cap nuts or donuts, and I can't remember which one I've used on mine. I think possibly these ones. Some of them do sometimes say metric on them. They're the kind of the ones to pick if you're not sure. Sometimes they are. They won't go small enough to your need, so some of these are coded and they'll be much larger versions, but we'll try that one for the case of what we're doing. So KSB 1026, which is a metric one, and we get a small metric one. Let's just try this small metric one just in case. So here it is. Now that's going to put a cap nut in there. Notice next to your cursor there's a little question mark. It's asking you to locate the end of the threaded bit where you want to put it. So if I hover over here, okay, Inventor will do some thinking about it. Now, perfect there, we've got pick one, which is the metric small, and it's telling us that M8 is the smallest size it can do, which is why it's gone red. So the size is not available for our M5 bar. So I'm glad I picked that just to kind of highlight that. Sometimes you get them. We'll try this metric one and just see if that one does work. Okay, so that one will work. We've got a green tick, look, so it's found the thread. So we need to do 2 clicks when we do this. It picks the thread up, and I can click, and then it asks it where it wants to sit. Do I want it on the end of the bar, or do I want it flat to this face? Well, in this case, I want it flat to the face in that case. Let me just explain that again. So we've gone place, we've clicked on the one we want. I'll just twist this around just so you can see this placement a little bit better. So I'm hovering over the end of the bar. It picks up M5. That's not where we want the bolt to be though. We want it to be flat to the back of our project. And we're going to just click this green tick, which will auto drop that into position. So we'll just click OK. And we are now left with our cap nut exactly where we want it. So we need to repeat this a few times. So M5. As soon as you've done it though, you can be relatively quick here. So we can pick the thread up, pick where it wants to be, click the bit. I'll just spin around just so we can see these next ones. So again, pick the thread, pick the flat bit, click the green tick. Okay. What do the other options do when I'm doing it? If I click onto here and then I just press this one, that's going to change the size. So it might bring a table up there and it allows us to pick a different size. I don't know why we'd want to do that because we need an M5. And if I just use this one, this just places the current one that we're doing, and then I would have to go back to play some content center. So the auto drop is the best thing here because it finishes that particular one and then it keeps it viable like when we're doing our placing our parts in order for that to work. So in this case I could do this one, this is my last one. I could do that one and then the tool's gone away, look, so I might just make it a little bit quicker for what you want. So here's the depth gauge. Now it's stood up. It's stood up, whereas the one on your drawing's probably laid down on the feet here. So there is a way we can fix that. This doesn't want to be our front, so we've not really explained this in any of the lessons, but the plane that you pick to draw on does make a difference in reality when you come to do things like assemblies, because we've drawn on the XY, which is why it's looking flat onto the object. If I was to rotate this cube round and say that actually this was going to be the front, I could right click in the center of my cube, I could go set current view as, and I could change that one to the front. And then if I click on this top corner, that's the view that I started with at the beginning of this video, and the one that you may need to put on a drawing, and the one that looks nice. It's an isometric view, which is a very popular view for engineering and manufacture related industries. Now when I press the little home button, it's always going to go back to that. Okay, now I don't want it to go to that, I actually want it to go to the view that we really wanted. So again, if I just click on this front top corner, that's the view I want. So again here, if I click my click on the cube on that corner and go set current view as home, okay, the home is the little house button that I was clicking a moment ago, and then if we say fit to view, now when I rotate around my shape and press the little house button or the home button, it now goes back to that. Now if I'd have drawn these on a different plane other than the XY plane, they would have automatically appeared maybe in that orientation if I'd have picked the right one. Okay, so we always pick the XY plane from an educational point of view, but actually in reality sometimes it is easier to pick the other planes because it makes it slightly easier. You don't need to follow those last few steps we've just done with the cube in order to do it. And it wasn't, you know, a massive amount of work. I clicked on the face that I wanted to become the front. I right clicked and just said set current view as front. I then clicked on the upper corner of my cube to get it into the isometric view, and then again I right clicked and I said set current view as home, and then I clicked fit to view. So it's not a long process anyway, but sometimes if you pick a different plane, it may just stop the need for doing that particular bit. So once we've got that, the next stage would be to kind of try and do a drawing. I've not made a video for that particular one because, you know, you've done a drawing for your depth gauge. You know, I could keep making videos on exactly how to do drawings, but it's very, very similar in nature to what you do. You're going to place your views on, and then you are going to put some annotation on there. You're going to put some dimensions on there, and maybe some additional views of your project. Okay, so that should make the parts, should allow you to do the assembly as you are working.